Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of first year chemistry. We have started a discussion with atomic structure in our previous sessions. We learned about different concepts of atom and electrons and all other subatomic particles, right. We also studied about few properties of that such as Hund's rule, Pauli's exclusion principle and so on. In the last session we started a new chapter, that is periodic classification, right. What did we study in that? We have seen the different concepts such as the basic what is the need of classification, what are the basic classifications. We have started with the Dobania, we have continued with the Newland, then we discussed a few properties of Mendeleev and Moseley's periodic table, isn't it? What did we conclude in the last session? In the Moseley's periodic table we have a long form of periodic table which is actually being designed and tabulated based on its atomic number, isn't it, right? Fine. Based on that, today we are going to study about this long form of periodic table which was actually initiated by Moseley in his periodic table. Okay. What was the main property of Moseley? He modeled the whole periodic table only based on atomic number, right. He arranged all the elements, almost all up to 108 elements in an different structures, right. Let me not use the particular term. What are the terms are, he arranged the whole thing in the terms of rows and columns. Those are nothing but groups and periods. Hope we discussed about this group and period in the last session, right. What is a group? A group is arrangement of an elements in vertical way or else in the column, okay. And what are the rows? Rows are nothing but are periods, okay. That's why it is actually a simple name called as periodic table, okay. Fine. See here, this is a complete long form of periodic table. You can see in your textbook, I didn't draw all the elements, but there is the overall view of a basic long form of periodic table, right. How did he design? He divided the whole periodic table into number of periods and number of groups. How many periods? That is, he divided the whole periodic table into 7 periods and 18 groups. What are periods? Periods are horizontal rows and groups are vertical columns, right. The whole table is divided into 7 periodic rows, okay. 1, 2, 3, 4, 5, 6 and one more is nothing but this hydrogen and this last element. Is it clear? In that way he divided the whole thing into 7 periods. Here it is 1, 2, 3, 4, 5, 6 and 7 periods. How many groups? Again totally 18 groups. See here, here 2 and here 10, that is, see here you can see from here 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, okay. Again in this block he divided into 6 places, 1, 2, 3, 4, 5 and this is the 6th one, right. There is one more block here, okay. What are those all? Let us discuss now, shall we? See here, what is the first point? You have to remember, the first point is the whole periodic table is divided into 7 periods and 18 groups, done, fine. And the second thing is he divided the whole periodic table into different blocks. Initially he divided into one block, that is representative elements. Remember the term representative elements, those are nothing but S block and P block, right. S block, why the name is given as S block? See here, let us see first thing. See here, this whole part is S block, right, and this whole part is my P block till here, right. Did you understand? Hope you know what are s orbitals and p orbitals, right. S orbital, it has 2 electrons in it, right. In most of the elements such as sodium, magnesium, right. What is the electron configuration of sodium? 1 to 2p6 and 3s1, which has the valence electrons in s orbital. Such elements are placed in s orbital, or else we can simply conclude it as the elements whose valency is an s orbital, right. Those elements are placed in s block, right. Hope you can understand the p block now, right? What is a p block? A p block has elements in which it has a valency of only p orbitals, right? Hope you can understand, right? S orbital has 2 electrons, that why it has 2 groups, or else you can simply tell it as 2 columns, okay? And how many electrons do p block have? P block have 6 electrons, therefore p block will have 6 groups. How many now totally? 2 s block, 6 p block, totally 8, right? Fine. And the next, this is d block elements from here to here. D block elements, how many electrons do d orbital have? D orbital have 10 electrons in it, therefore it will have 10 groups. Is it right? Did you understand? Once again let me tell, s orbital has 2 electrons, that is why it can accommodate 2 electrons. The first electron element will be in the first column and the second electron element will be in the second column, right? When it comes to p block, is a block in which it consists of elements whose valency is a p shell, that is a p orbital. Since it consists of 6 electrons, therefore it has 6 groups, right? First electron, second electron ka element, third electron, right? Hope you can understand, right? That for example, let us consider this element. This element has a last valence electron, that is only 1 electron in the p orbital. This atom will have 2 electrons, this atom will have p electrons in the, 3 electrons in the p outermost orbital, and finally this is a special group which has a hole filled, that is all filled orbitals, right? This has a p orbital, right? P orbital with almost 6 electrons in it. And one more thing is d orbital whose valency shell is a d orbital, right? A d block is a block in which its materials consists of a valence d orbital, right? Which means for example here d orbital with 1 electron, d orbital with 2 electrons, like that till here, right? And there is one more thing, that is an f orbital. This is an f block. These are actually a part of d block elements and this consists of 2 rows. The one is actinoids and one is lanthanoids. Let us discuss again in deep, right? What did we learn? There are 4 blocks, that is s, p, g and f. And one more thing is s orbital will have 2 columns, p orbital will have 6 and d orbital will have 10, totally 2, 6 and 10, totally it will be 18 groups. Did you understand, right? Fine. Let us discuss about its electronic configuration. If I observe here, it might be ns, whether it is 2s1, 2s2, 2s3, 2s4, 2s1, 2s2, right, in the first electron, fine. And in the second row, that is in the second period, 3s1, 3s2, in the third period, in the fourth period, 4s1, 4s2, isn't it? Like that we can go up to 7s1, 7s2. Therefore, the general electronic configuration of s block elements is ns1 to 2. It might be ns1 or ns2. N ranges from 2 to 6. However, hydrogen is in the first row. However, its configuration is ns1, right? That is 1s1. Clear? Fine. When it comes to p block elements, however, it has to pass from ns2. Isn't it? It has to pass from ns2, then it goes into np, right? np 1 to 6. For example, if I consider after second row, if I want to find the electronic configuration of this element, I do not know the element, I do not even know anything there. Which row it is? The period number is 2, 3 and here the period number is 4s2, and what about this? N will be 4 p1. This is the valence electronic configuration of this particular element. Fine. Then what about this last group? It will have always np6, right? That is the general electronic configuration of 0 group is ns2 np6. Clear? What is this last group? Right? That has a special significance, that is actually called as 0th group elements, and that is the last corner group, right? That is the 18th group. that is called as 0th group or 18th group, and it has a fixed standard configuration, right, because it has the orbitals which are completely filled, isn't it? Not only that, these are a stable configuration. See here, ns2 np6, which means it has 8 electrons in the outermost orbital, that is, it has octet configuration. Therefore, the 0th group elements are the stable configuration, that is why they are called as noble elements. Okay, they are nothing but the noble gases, they are the inert gases because they have highly inerting feature, that is why they are called as inert gas elements. What are the different names it has? Once again, they can be called as 0th group, they can be called as 18th group elements, or they can be called as inert gases, or they can be called as noble gases, because they are highly stable, because the outermost orbitals of these elements are completely filled. Is it right? The outermost orbitals of a 0th group elements are completely filled. Fine. What is the general configuration? ns2 np6. What are the elements? Hope you all know these popular elements: helium, neon, here it is argon, krypton, xenon, radon, and the last element is not yet discovered, because that is the last row and last element of that particular column, right. There is a last most element which is not yet discovered. Hope it might be discovered in the future, right. Once again, what are 0th group elements? 0th group elements is the last most group. Okay. And one more thing, if you observe here, 1A, 2A are the two groups of these things, right. These are popularly called as metals and these are popularly called as non-metal. Let us discuss again in one more topic. And again 3A, 4A, 5A, 6A, 7A, it continues here, right. And this is finally, it cannot be considered as 8th group, but okay, in some textbook they refer it as 8th group, but actually we always study it as 18th group or 0th group, right. Since everything starts from 1 to 7, we have already used the term 8, this is the they named it as 0th group. Okay, 0th group elements, 18th group elements, inert gases and noble gases and the stable elements, everything is fixed for this name. Is it clear? Fine. What are the elements here? Helium, neon, argon, krypton, xenon and radon. And what are the electron configuration? General electron configuration is ns2 np6. N might be starting from 2 to 2s2, 3s2, 4s2, 5s2, 6s2, 7s2, and the last thing is not yet discovered. Clear? Did you understand? Fine. And the next is D block elements. D block elements, it has 10 groups in it, starting from 3B, 4B, 5B, 6B, 7B, then here 1B and 2B, including the 3 8th group elements, right. Is it fine? There are 10 groups starting from 2B, I mean 3B, 4B, 5B, 6B, 7B, then 1B and 2B, here 8th group elements. Fine. And what is the general configuration? N minus 1, D 1 to 10 and NS 1 to 2, right. NS 1 to 2, that is fixed. It might be NS1 and NS2 based on its configuration. Most probably it will be NS2, there is no doubt in it. But based on the stability criteria and in order to follow Hund's rule, we have to change this NS1 to 2, right. Fine. Based on that, this N minus 1 value, it changes from this to this. For example, if N is 4, this will be 3D. Okay. How the configuration of this element will be? For example, let us consider this element. This element is N is 4, right, that is in the 4th period, which means this element will be 4 minus 1, 3D, first, second. This is second group of D block, and 4 S already here 1 is done, 2 is done, therefore it is 4s2, right. Based on the calculation and simplification, it depends on the atom, right. Based on that, we will change this NS ka value. Clear? Fine. Once again, let me tell, S and P block elements are called as representative elements, and the 0th group elements are called as noble gases or inert gases, whereas the D block elements are called as inner transition elements. Transition elements. Why they are called as transition elements? because these acts as a transition from this part to that part, that is from S block to P block, and not only that, it can be simply called as transition from metals to non-metals. Most of the P block elements on the right side are always non-metals, on the left side of a periodic table they are metals, right. This kind of transition from this side to that side, that is called as transition elements. And not only that, transition elements, transition, the term itself, it tells that it lives for a very short time, right. These elements are also that kind of metals, most of them are metals again, right, and a few of them are metalloids. What do you mean by the term metalloid? They are neither metal nor non-metal. Is it fine? Fine. This kind of things we will see again in the future example. We will study each and every group. Do not forget, by the end of the second year, our textbooks will make you clear about each and every group, that is from the Verney, two-way and up to the noble gas and everything, right. Not only in the first year, we will discuss most of these groups in our second year chapters. F block elements, how many electrons do F orbital have? F orbital will have 14 electrons in it, right. 14 electrons means obviously it will have 14 groups, right, and these F orbitals are popularly called as inner transition elements. Why they are called as inner transition elements? Because these are taken as a patch of transition elements, right. Why these are being kept separately is they have a different separate orbital, that is F orbital, and these are atoms which have a special feature which has a transition elements ka feature and some other features which are being unique, right. That is why after lanthanum, that is after 57, they started from 58 to 71 as a single row, and after that again from 72, that is from hafnium, they again placed in this row, okay, that is in the period, right. That is why since the elements are started from the lanthanum, these row or these period elements or the first period of F block are called as lanthanides, right. Similarly, in the second, in the last period itself, the element 89 is actinium and the RF rutherfordium is 104. All the elements between 89 and 104, that is starting from 90 to 103, they are called as actinoids because the element after which we are starting it is actinium, okay. Is it clear? Try to remember these words, these numbers 58 to 71. As soon as 57 lanthanum, we are going to F block elements, and the next will be after actinium we are going to actinoids. Is it clear? Did you understand? And what is the general configuration? Obviously NS2 will be there. When it comes to N minus 1, N minus 1 goes from 0 to 1, right, either 0 or 1, right. Before this there is nothing, right, either it will be 0 or 1, most probably 1, and F, it always continues from 1 to 14 because it starts from first group to the 14th group of a F block elements. Did you understand? Fine. And not only that, there are a few more things to understand. What did we learn about one property? We learned that all the left side elements will be metals and all the right side elements will be non-metals. Then how are they varying? From the left side to right side, he arranged the elements in such a way that its metallic property reduces, right. Now I can tell that this particular first group are called as pure metals or the highest, or the properties with highest metallic property, right. That is why this element are called as, or else this first group elements, that is 1A group elements are called as alkali metals. Alkali metals, try to understand the word alkali. Hope you know that what is an alkali, right, which forms an oxide, fine. For example, potassium hydroxide, sodium hydroxide, right, fine. And after that, and these elements are called as alkaline earth metals. There are few groups like this for which we have to remember the names of the group, and the name of this group, however you know, that is nothing but 0th group elements. And what about the other things? If they do not have name, they popularly name with the first element of the group. Hope you know, right? Shall we fill a few of the elements? Now let us see. Hydrogen is 1, helium is 2, 3, 4, 5, 6, 7, 8, 9 and here is 10, 11, 12, here 13, 14, 15, 16, 17 and here is 18. Okay. After 18 it starts with 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35 and here it is 36, right. We always know that the stability or the fixed contains it is based on 2n square formula, isn't it? If it is in the first row, if n is 1, that is 2 into 1 is 2, that is it will have only 2 elements, one is hydrogen and one more is helium. When n is 2, 2 square is 4, 4 to the 8, it consists of 8 elements. When n is 3, 3 square is 9, 9 to the 18 elements in the next period. Is it right? Did you understand? Again it continues to be 18, 18, 18 and so on. Clear? Once again if you observe, in the first period it will have 2 elements, then 8, 8, then 18, 18, 18 and 18, 1, 2, 3, 4, 5, 6, 7. Is it clear? Did you understand? This is how we learn the electron configuration, right? Fine. Based on that only we will fill the each and every orbital. Clear? And what are the different names here? If it is phi is boron, it does not have any name, that is why it is called as boron family. 3a group is called as boron family, 6a group is called as carbon family, right, like that we usually call, and there are different names for 7 and 5th and 6th group, whereas this 7th group elements, that is under the fluorine, these are popularly called as halogens. Remember, halogen is almost all non-metal elements, that is in the last group. Is it clear? Did you understand? Fine. What all we discussed in this lesson? We started our discussion of long form of periodic table, right. We learned that the whole periodic table is divided into 7 periods and the 8 groups, right, based on the number of blocks. After that they divided the whole thing into 4 blocks, that is S block, P block, D block and F block, right. Among them S block and P block are called as representative elements, D block is called as transition element and F block elements are called as inner transition elements, right. And we have already know that all the elements are placed on the left side of periodic table and all the non-metals are placed on the right hand of the table. And not only that, if you observe, what about the middle elements? Are the metals or non-metals? Fine, there are neither metals nor non-metals, and you have to observe few of the elements of the transition elements and P block elements are metalloids, which are neither metals nor non-metals and popularly called as semiconductors. Hope you would have heard about this name, right? Clear? What are those? Silicon, germanium, arsenic, indium. This kind of elements are popularly called as semiconductors, or simply in your name semi-metals, right. They are neither metals nor non-metals. They are arranged in a stepwise manner, one element here, one element here, one element here, one element like this. Clear? Did you understand? Fine. There is a broad overview of a long form of periodic table. We understood one thing here, that metallic property varies from left to right, isn't it? Metallic nature reduces from left to right and non-metallic nature increases from left to right. Fine. This is one of the variation of a metallic property. Clear? Fine. There are a few more properties and variations of this periodic table, not only metallic nature, but also its atomic size, ionization energy, electron enthalpy, and the different things which we have to discuss in the further session. Fine. Clear. Let us discuss about the variations of such periodic properties in our next session. Clear? Fine. This is for today. Let us meet in the next session with a new topic of periodic classification. Thank you.